Hello everyone, welcome to our channel. Myself, Pranjal Gaikwad. Today I am going to present the topic of thermogravimetric analysis, which is guided by Dr. Vijaya Barkimam and presented by myself, Afia Sheikh, Anis Amullah and Vaishnavi Madure. In this, we'll see the introduction of thermal analysis, its definition, its introduction, types of TGA, then principle, its transition types, the graphs included in this, then instrumentations, then basic block diagram of the thermobalance, then factors affecting TGA curve, advantages, disadvantages followed with their applications. So let's start with our topic. So starting, we'll see the definition of thermal analysis. So let's start with the definition of thermal analysis. So basically, thermal analysis is a branch of material science and a group of analysis which studies the property of a material when it changes with the temperature. Means it detects or analyzes the property of a material with respect to its temperature when subject to temperature. And second thing is that here in this technique, mass of substance is measured. Then it has further types of the thermal analysis. So types of thermal analysis are TGA, that is thermogravimetric analysis, DTA, that is differential thermal analysis, DSC, that is differential scanning colorimetry, thermometric titration, dynamic mechanical analysis, and thermomechanical analysis. Now we'll see in depth what exactly thermogravimetric means. So basically, thermogravimetry is a branch of a thermal analysis which examines the mass change of a sample as a function of temperature, that is in the scanning mode, or as a function of time, that is in the isothermal mode. This means it basically examines the mass change of the sample when it is subjected to temperature with respect to its function of time. Thermogravimetric analysis is a method of thermal analysis in which changes in physical and chemical properties of the material are measured, which means in this technique, the physical and the chemical properties, both the properties of the material are measured with respect to its increasing temperature rate or as function of time. Next are the types of thermogravimetry. So there are three types of thermogravimetry. First is isothermal or static thermogravimetry, quasi-static thermogravimetry, and dynamic thermogravimetry. So isothermal or static thermogravimetry means in this technique, sample weight is recorded as a function of time at constant temperature. Means here at the constant temperature, the sample weight is recorded or examined. Next, quasi-static thermogravimetric means in this technique the sample is heated to a constant weight at each of the series in increasing temperature. So basically here at initially we saw that the temperature was kept constant, but in quasi-static thermogravimetry here the temperature is kept increasing, and according to the increasing temperature the sample is detected. Then in dynamic thermogravimetry, in this technique, a sample of heated in an environment whose temperature is changing in the temperature manner, generally at a linear rate. So in dynamic thermogravimetry, at linear rate, the sample is examined. In thermogravimetric analysis, the sample is heated in a given environment, that is air, N2, CO2, helium, argon, etc. At controlled rate, the change in weight of the substance is recorded as a function of temperature or time. The temperature is increased at a constant rate for a known initial weight of the substance, and the changes in weights are recorded as a function of temperature at different time intervals. So basically, the weight of the substance is calculated and examined with respect to different time intervals. And then the plot of the graph is done against the temperature. This is called the thermogravimetric curve, where we plot the graph of weight against the temperature. That is called as TGA curve. It has two types, physical transition and chemical transition. In physical transition, it includes adsorption, desorption, sublimation, evaporation, and vaporization. In chemical transition, it includes oxidation, reduction, chemosorption, loss and drying, and degradation. Next, we'll see the types of graph. It includes desorption, adsorption, polymer analyte, loss and drying, oxidation, followed by decomposition. Now we'll see instrumentations. Components of instrumentations are recording balance, sample holder, furnace temperature programmer, or we can say controller, recorder. Now this is the basic block diagram of a thermobalance. As you can see here, it contains sample holder with the recorder which records the function of the sample. Here furnace, then at the above we have atmosphere control. Below it we have recording balance control with the furnace temperature programmer which controls the temperature, and we have a temperature sensor. So this is a basic block diagram. So these TG curves are recorded using this thermobalance. It consists of the various components such as microbalance, recorder balance, sample holder, furnace, recorder, data recording unit, heating rate, time measurement. So first we will study about microbalance. So it's a most important component of a thermobalance. It is used to record a change in mass of the sample or the substance. An ideal characteristics of the microbalance should be that it should provide electronic signals to record the change in mass. It should have the capacity of auto wait. Its operating should be user friendly. Modern microbalances have the ability to not get affected by the vibrations created. Then next we'll study about recorder balance. So there are two types of recorder balance. First is deflection balances and second is null point balances. In deflection balances, we have types like beam type, helical type, cantilevered type beam, torsion wire. Next, so what does deflection balance means? In this balance, the conversion of the deflected beam takes place into the weight change. In this balance, elongation or contraction of spring occurs with change in weight, which is recorded by help of transducer. In this, the beam is attached to hard torsion wire which act as a fulcrum. In this balance, one end of the beam is fixed and on the other end sample is placed. Second is null point balances, which means it consists of a sensor which detects the deviation from the null point and restores the balance to its null point by the means of restoring force. Next is sample holder. The sample to be studied is placed in sample holder or crucible. It is attached to the weighing arm of the microbalance. So basically there are different types of the crucibles which are used. First is shallow pans, then deep crucibles, loosely covered crucibles, retort cups. So these are the different types of the crucibles which are used. They are basically made from platinum, aluminium, quartz, or there are some other materials also like graphite, stainless steel, glass, etc. Next is furnace. So furnace should be designed in such a way that it produces a linear heating range. It should have a hot zone which can hold sample and crucible, and its temperature corresponds to the temperature of the furnace. So its temperature must be corresponding to the furnace. Third is the temperature range. Temperature ranges can affect the internal atmosphere of the furnace chamber. Therefore, it is necessary to choose specific type of the furnace according to the temperature ranges. So here, selection of the furnace according to the criteria is most important. Coils used are made of different materials such as nichrome wire, platinum with 10% rhodium or alloy. The size of the furnace is very important. Next, we'll study about the recorder. So, the output from the microbalance and the furnace are recorded using either chart recorder. The recording systems are mainly of two types: time-based potentiometric strip chart recorder and XY recorder. In XY recorder, we get curves having plot of weights directly against the temperature. However, the percentage mass change against temperature or time would be more useful. Next is heating rate. So, it's a rate of temperature increases which is in degrees per minute. The heating or cooling rate is used to be constant when the temperature or the time curve is linear. Time measurement. It is done by thermocouple. Different materials are used for measuring different ranges of temperature. That is chromal. For example, the chromal thermocouples are used for the temperature which are 1100 degrees Celsius. Next is factors affecting the TG curve. There are various factors which affect the TG curves, which includes the instrumental factors. Sample characteristic includes weight of a sample, sample size, heat of reaction, compactness of the sample, and previous history of the sample. And under instrumental factors, it has furnace heating rate, furnace atmosphere, and sample holder. So all these factors affect the TG curve. Next is instrumental factors. So we'll see here how the instrumental factors affect the TG curve. So first is furnace heating rate. The temperature at which the compound or sample decompose depends upon the heating rate is high. The decomposition temperature is next is furnace atmosphere. The atmosphere inside the furnace surrounding the sample has a profound effect on the decomposition temperature of the sample. A pure nitrogen gas from a cylinder passed through the furnace, which provides an inert atmosphere. Next is sample characteristics, which includes weight of the sample, particle size of a sample. So first is weight of the sample. A small weight of a sample is also recommended. Using a small weight eliminates the existence of the temperature gradient throughout the sample. And in particle size of a sample, we need to keep the note that the particle size of the sample should be small and uniform in nature. The use of the large particle may result in apparent very rapid weight loss. Next are the advantages. Accurate and precise method of macro quantitative analysis, low detection limit, which is up to 10 to 7, reliable data, easy to use, minimal sample preparation, capable of conducting isothermal experiment and cooling experiment. Next are the disadvantages. So disadvantages are destructive, that TGA can be destructive also. Limited range of samples are allowed and required meticulous time consuming. So this method is a bit time consuming, usually not qualitative. Misstep in the procedure can lead to error for analysis. The applications are physical transition, chemical transition, loss in drying, purity of analyte, stability of analyte, then the determination of bound and unbound water, which begins at the room temperature. TGA, that can be determined the purity also, and the thermal stability, both of primary and secondary standard. Then we can study about the corrosion, that is corrosion studies. Automatic thermogravimetric analysis also can be performed, and lastly evaluation of the suitable standards. And these are the references. Thank you.